Hello everyone! Chapter 3, Learning Target 8, Piecewise Functions. Yes, this Miss Osier.
And Miss Lahar.
Piecewise functions are so much fun.
Yes, this is a lot of words. They can be expressed algebraically, and sometimes they're more complicated, involve different equations from different portions of their domain. These are known as piecewise functions. So basically, you have pieces of functions.
Pieces, and you gotta put them together like a puzzle, people.
And you have different domains. So for example, this one right here, when x is less than 4, you're using 3x minus 5.
Wait, when x is greater than 4, you're using 3x minus 5. When x is less than or equal to 4. We can read. It's morning time for us too here, people. All right, so you input 7. Now, you can't just pop 7 into both. You have to pay attention. 7 is bigger than 4, so 7 would go into the top.
Intervals. Oh, look at this. Included, not included.
Beautiful.
Look at all those animations.
So 3 times 7 minus 5 is 16.
So
Perfect.
f of 7 is 16. So when your x value is 4, you would plug it into the second piece because x is less than or equal to 4.
So you have negative 16 plus 2, which is negative 14. So f of 4 is negative 14. It's that simple, people.
Mm-hmm.
Okay, so we have an absolute value. Now 4 is a constant. This is just like y equals 4. That's a horizontal line. You should know that.
Okay, and then we got a parabola. So you might be dealing with a bunch of different other things. Must be that the next question is g of negative 4.
So negative 4 falls into less than or equal to 1. So we substitute negative 4 in. Remember, an absolute value will change that negative 3 to a positive 3. And you will multiply that by a negative 2, make it negative 6.
So g of negative 4 is negative 6, because remember, it's all about perfect notation. Now,
Boom.
2. 2 is definitely between 1 and 3, so we've chosen 4. So that's why g of 2 is just 4.
That's an easy one. It's
Don't
just
make
boom,
it
4.
complicated.
So for the piecewise linear function given, find all solutions to the equation f of x equals 1 and where y equals 0 algebraically. So now this is a little tricky.
Yep.
Okay.
So they don't give you your x values. They give you what y value they want to pop out. So in this case, if y is 1, you have to check where it's going to be 1.
So we have to check both because both could have an output of 1.
Yep. So you solve both of the equations and then check the domain. Is 9/2 less than 0?
Nope.
Definitely not, so it doesn't work. Now let's go to the other one. So we add 2, divide by 5, we get 2/5. Is 2/5 bigger than 0?
Yep.
So that one works. So x equals 2/5 is going to be your only answer for where y is equivalent to 1.
Okay.
So
So
one
again, you have to, solving it is not the problem for anyone. Everyone's going to remember to set each equation equal to the statement
Value.
given, the value given. Here's where you have to be careful. Because it was on the negative 2x plus 10, you have to see, did that value you solved for actually exist on that interval?
Yep. So it's a little complicated. So that one would work. So the only answer would be x equals 5. Why is that so big?
And we should also be solving for where y equals 0, but I think we just skipped it, which is fine. But
No, I think it comes up.
is
Hold
it
on,
there?
go back.
I don't see
Yep,
it.
right there.
Oh, boom, there it is.
Why 5x equals 1 is at the top of your paper.
really
I have no
big.
idea. Very big. All right, so you would solve both
Okay,
those.
it's over here.
Oh my God, that's hilarious.
This is the first step for over here. Okay, so again, we set it equal to 0. Sorry, we're having fun. We get x equals 5. X equals 5 is not less than or equal to 0, so that one's gone.
Okay, we solve this one. Oh, it's right. So why?
See, look, it's big and it's here too.
We get x equals 1/5. Is that bigger?
Yes, it is.
So that's your answer.
Boom, it is bigger than 0.
Wow.
Define the x and y intercepts for the piecewise function. Okay, you need to remember this. X intercepts are where y is 0.
Y-intercepts are where x is 0.
So the y-intercept is going to be the easier one to find.
Which one did? Oh, look at those
That
points.
was really nice.
It looks like I solved for our x-intercepts
So
first.
we have to solve on each piecewise function because each function could have multiple x-intercepts. We don't know.
Right. So I solved, and now absolute value is a little stretch for you guys because we haven't reviewed it. But remember, you need that quantity to be 0. Well, it's the only thing that you could plug in there to get that equals 0 is negative 1.
Mm-hmm.
Negative 1 does fall under the interval, so we're going to keep it. 4 equals 0 doesn't work.
Nope.
This one, the only way we could get it, it would be x equals 0. But again, that doesn't count underneath the domain.
So in this case, we only have one intercept, but I want to be clear. You can have multiple intercepts for
Yeah.
x-intercepts.
Why is you can't? Because remember, these are all functions, so they do have to pass the vertical line test.
So we go where x is 0, that would fall in the first interval, and we solve.
And then the y-intercept is negative 2.
So intercepts will be written like we have here as coordinates. So negative 1, 0, and 0, negative 2 are your intercepts. That's it, everybody. Have a wonderful day. We will see you in class.